Hi, I'm Alex, and today we're going to be taking the derivatives using product rule. When taking the derivative using product rule, we're timing f of x, which is your first term, times g of x, which is your second term. So you take the derivative of the first times the second, plus the first times the derivative of the second. Our first example is just a simple two-term problem, which is 4x plus 3, which is your first term, times the second term, which is 3x squared minus 1. So when putting this into your problem, you're going to take the derivative of your first, which is 4, and then that's going to be times the second. So you just leave it as it is. Then you're going to do plus the first as it is, times the derivative of your second, which is 6x. And then to simplify this, you just go ahead and multiply it all out, which is 12x squared minus 4 plus 24x squared plus 18x. And then you just add like terms, so it's going to be 36x squared plus 18x minus 4. And then you're going to, when you finally get the answer, you're going to look and see if there's anything that you can take out, and the only like term would be a 2, so you can take a 2 out of everything and get 18x squared plus 9x minus 2. And then you're done with that one. Let's try another example using trig. Okay, our next example is going to be f of x equals x squared sine of x. Okay, so our first term is x squared, and it's going to be times the sine of x. So when taking the derivative of the first, it would just be 2x. And then you're going to times it by just the second as it is, so sine of x. Then you're going to add the first as it is, x squared, times the derivative of your second, which the derivative of sine x is cosine x. And then you're just going to multiply it all out again, which is 2x sine of x plus x squared cosine x. And then you're done. And now Taylor's going to show you quotient rule.
Okay, quotient rule is actually very simple as well when taking derivatives. It states that when taking the derivative of f of x divided by g of x, you're going to take g of x times the derivative of f of x minus f of x times the derivative of g of x, all over g of x squared. And an easy way to remember this is low d high minus high d low all over low low. Our first example is x squared plus 2 all over x minus 1. So first we're going to take the bottom and multiply it by the derivative of the top, which would just be 2x. Then you're going to subtract the top, which is x squared plus 2, times the derivative of the bottom, which is just 1. And you're going to put all of this over x minus 1 squared. So then we're going to multiply out, and we get 2x squared minus 2x minus x squared minus 2 all over x minus 1 squared. Then we can combine our like terms, and it actually comes out to be x squared minus 2x minus 2 all over x minus 1 squared. And remember to write that the derivative of f of x equals that. So our next example includes trig, but it's still the same concept as before. We have f of x equals cosine of x over 2x. So same thing, we're going to take the bottom, which is 2x, times the derivative of the top, and the derivative of cosine x is negative sine of x, minus the top, which is cosine x, times the derivative of the bottom, which is just 2, all over the bottom squared. So now we can multiply out. We have negative 2x sine x minus 2 cosine of x over 2x squared. And actually, if you look at the 2x in front of the sine x and the 2 in front of this cosine x, we can simplify and make it a negative sine of x over 2x minus cosine x over 2x squared. Because right here our 2 cancel out, and right here our 2x cancel out. And that gives us the derivative of f of x. Thank you.